Hi, in this video I'll show you how to make this 3D printing effect. We will import the 3D model into the Specialized software, adjust the shape and fill density, and then export the result as splines in Cinema 4D for further animation. We'll make a simple 3D printer rig in two versions. I'll give you a couple of tips on rendering and also tell you if I managed to print something. Thanks to Ruslan for the 3D printing technique. Check out his Telegram channel and give my regards. So let's get started. To start, we'll need a ready-made 3D model in one of the appropriate formats. You can use not only STL models after CAD programs, but also the more familiar OBJ. I modeled this statuette in Volume Builder and will show you everything on it. The shape is more complex than any cube, and this is useful for me to demonstrate. But we will also try the cube. Export everything to OBJ. Next, we need a slicer. Go to the UltiMaker website, download Cura 3D printing software for your system, install it and open. We are greeted by the primary configuration window. Agree. Next, skip logging into your account, select UltiMaker printer, add a local printer and go to unconnected printers. I leave the first one, they differ for our task only in their size. Skip. The orientation here goes like this. The right mouse button is for rotating the camera, holding the mouse wheel for moving it, and scrolling the wheel for zooming it. Let's import the model right away. This can be done either via File, Open File, or by transferring from the Explorer. You can load multiple models to a single scene, therefore, in addition to the statuette, I will also load a cube to demonstrate some settings. My models were imported on a small scale, and now we will fix it. Click on the model. A window appears on the side with tools that are familiar to us. This is a move, this is a zoom, and this is a rotation. So I take each of the models, increase them in size and rotate them as needed. Let's make the first test slice. This section contains all the necessary settings. I'll set resolution to extra fast and click slice. Slice has been prepared, but to view it we need to go to the preview tab. You can close the settings. When you get closer you can see the details. And with the help of this slider we can see the layered operation of the printer and the filling of the models. Since we will continue to transfer information from this application in the form of splines, then we need to optimize the number of segments, which we will do now. Open the settings panel and switch to custom mode. All settings that will be discussed later are individual for each case. I'm just showing you the functionality and you're already starting from your models and tasks. The first parameter, quality, affects the layer height. The default value is too small, so we need to increase it, but before that, pay attention to the number of layers. Our goal is to reduce them, so let me put 1 mm and click slice again. Both the number of layers and the overall height detail of the models have been reduced. Here I recommend paying attention to the shape of layers. In my case they are stretched vertically, if you look at the orange layer for example. I would like them to have a more rounded shape, so in the future I will reduce the size of the model. Accordingly, the shape of the layer is regulated by the ratio of the layer height to the size of the model. I got 179 layers. You can actually make it a little bigger, so I changed the size to a smaller one and click slice. I think the range from 200 to 300 layers is optimal, but it all depends on the task and detail of the object. The next parameter is walls. It adjusts the number of walls. If we zoom to the models and look at their walls, then the first layer is red and the second layer is green. So the green one can be removed. If you change it to 1 and click on slice again, it will become one less wall. You can try to remove the walls altogether. it will turn out such a structure, which is also interesting. I would leave only one outer layer for optimization, but gaps appear in the surfaces at an angle, so for a more dense structure I will return the second layer. The next are top and bottom. They're shown in yellow in the color scheme. Affects the layer density of horizontal surfaces. Using the example of a cube, I'll show you. This is its roof and this is its bottom. You can see that there are 5 layers. 1, 2, 3, 4, 5. This is a fairly dense structure. Moreover, such layers are added not only to completely horizontal surfaces, but also to surfaces at an angle. I think this is too dense a structure for my statuette. It will produce a huge number of points, so I suggest reducing the number of such layers from 5 to 1. This is the result. Next is infill. This is the content of models. In the color scheme it is made in orange. We can select the percentage of the form filling, as well as select the form of this filling. For the forms themselves, I will show you a small demonstration of filling in using the example of a cube. Filling here is approximately at the level of 3% of the cube's volume. Large values become much more difficult to work with due to the system load. Gyroid looks quite interesting, and lightning also works in a special way. It adds additional supports closer to the upper horizontal surfaces. This can be seen on the roof of the cube, as well as on the entire content of the statue where there are inclined surfaces. I'll choose gyroid, but keeps the content at 4%. Skip some of the items and go to the support option. You can use it to generate supports for the model. They look like this. As we can see, for the cube, these supports were not needed, and for the statuette the program determined this shape and this quantity. To complete our tasks, it seems to me that these supports can be removed, but someone might find this view interesting. I'll disable it. We move on to the last item of our interest, build plate. This is the base support, made in blue. I think this is also unnecessary, so by switching its type to none, we will remove it. I think we are done with optimization. I'll go to the Prepare tab, remove the cube, select the statuette and place it in the middle. I still feel like each other layer is stretched too far vertically. I want a more rounded shape, so I'll work on the parameters to get the desired result. In the end, I set the layer height to 0.5 mm, the statuette height to 88 mm, and the filling to 5%. There is another point that needs to be shown in advance. On the Preview tab in the color schemes you can enable the item travels, and we will have extra lines. As far as I understand, this is the trajectory of the head of the printer itself without the printing process, and this information will also be exported with the shared array as splines. We'll get rid of this later. After all the settings and the final slice, we save the result. Save to disk. Select the format. STL and OBJ will not work for us, because the program will simply return the same thing that we imported into it, but triangulates. Therefore, to get splines as a result, select the G-code format and save it. Next, you need to convert G-code to OBJ. I've tried several different converters and will leave a link to the one that works most predictably. We place the G-code file here and can observe a model with extra splines, which I warned you about. Scroll down and save it to OBJ. Import the model to our scene. Small tip: if you don't want to get into the merge project, so that the model is immediately added to your scene, and you don't want to create a new scene by dragging an object into the program field, then holding Shift, the model is imported directly into your scene. It was imported on a very large scale, rotated, with extra splines. Let's get this straight. I pulled the model out, the splines themselves, and delete the extra ones. Rotate it. The spline has a 90-degree rotation along one of the axes. Let's get it back. Now you need to center the spline. Adding the geometry axis, by y-axis I set -100%. I'll hide our model for now and we'll take a side look at the spline itself. We see that it is layered and there are connections. Let's turn on the previous model, apply a transformation to our spline, rename it, and reduce it in size. I'll try to fit it to the original model. This is not necessary, I do it for myself. I disable the original model and need to check our spline. We can see that we have 300,000 points, but if we get closer, and if we move at least one of them, we will see that they are different segments. You can also see them by their color, they start with white, end with blue, and so on for each spline. Accordingly, we have twice as many points as we need. This will affect performance. I couldn't weld them in Cinema 4D, because Optimize doesn't connect different segments, meaning the number of points doesn't change radically. Tracer returns the same result as the join segment function. It will create extra connections that we don't need. I cancel this action. And the connect generator simply hangs Cinema 4D solidly due to this number of points. Therefore, I managed to do this task only in Houdini. However, this will be an optional segment at the end of this video. We'll take a simpler way, but still, if you have Houdini, I advise you not to skip this step. So we are working with the spline that we imported, and let's start setting it up. I create a more spline, change its mode to spline, set display mode online, and put our main spline in the spline window. I hide the original one. We can now use the end slider to adjust the filling of the spline. You can pay attention to the fact that after filling in the entire shape, we have the same extra splines. We need to determine at what percentage they appear so as not to reach them. How can this be done? We move end to the end and start moving start. By doing this, we will now remove our entire shape and look at those extra areas and where they start. I reach the top. I want to get closer. Now with Alt held down, I reduce boost speed of these percentages and I need to get to the area where the last splines that are useful to me will disappear. Approximately at these percentages, 93.61. Let's see what we have on these percentages on the bottom. I don't see anything appearing, so we'll leave 93.61, and we'd better remember that number, so I'll create an annotation and hide it from viewport. I write here and 93.61. Next time I do an animation, I will insert this number in the end, and as a result I will have a clean spline without unnecessary elements. Now we need to add a thickness. The first thing that might come to mind is sweep. Let me show you why it doesn't suit us. I find sweep, make a circle, reduce the number of segments, I add more spline, and you can notice that the segments are separated, so welding splines and sweep doesn't occur. So we will weld them in a different way. I pull out more spline, remove sweep, and we'll do it using extrude. I put more spline in extrude, set the y-axis in extrude, set the height at which our layers will not intersect each other. 0.1, very close, maybe a little more, 0.11, almost reach each other. I can still increase a little bit. Crossing, let's decrease a little more. Excellent. Next we can weld it via connect. I create the connect generator, In the tolerance field for the weld parameter we set the lowest value, so that we only connect points that are very close to each other, and put them in extrude. The result is that the geometry is welded together. Next you can add the thickness using thickness generator. I put connector in thickness, reduce the thickness parameter to the smallest value, so that we don't have any geometry intersections. I can see intersections, so we need to reduce this parameter. 0.9, even less. 0.8, we are very close. Something like this. Some geometry can still overlap each other, so here you need to work with the shape that you got. Let's check the filling, go to more spline. Let's basically drag the end slider to our viewport. Specify the show always parameter. And we see that everything works for us. I see a problem with shading. It is solved by changing the font tag. First, we move it to the very top of the hierarchy, turn off use edge breaks and change the shading mode. You need to go through the options, but keep in mind that in this case we have geometry angles at 90 degrees. That is, we have straight vertical and horizontal surfaces. Between them 90 degrees. So we need 91 degrees. And now you can go through the modes. I think this shading mode is suitable for us. However, if you want to improve the shading, you can always round the geometry. This will increase the system load, but you can enable this option for the final render. In my render I did that, so I create a bevel deformer, put it at the top of the hierarchy. Let me reduce the spline value to a smaller percentage, and we will select the parameter for the bevel deformer. 0.1, even less, even less, we are close, 0.3, something like this. The layer shape is more rounded. I would settle on this option. When setting up the scene and animation, I recommend disabling additional deformers, so we will disable bevel for now, so that we have a general idea of the final view, but the system is not heavily loaded. At other times, the thickness generator may produce a similar result when the geometry intersects itself. In this case, you can switch the thickness mode to advanced. This increases resource consumption, so again you can leave basic for now, but switch to advanced before making the final render. I'll leave basic out for now. Next I will build a basic printer rig. Let's turn off the generators, all except spline. I will slightly reduce its length. Create a tracer, it will weld all the spline elements and create transitions between them. I put spline in tracer. Change the mode to connect elements and hide spline for now. You can see that we have additional segments where the head will move. I'll rename tracer to tracer connect, so I don't lose it. Create a null. Let's make a null of the locator form, reduce the size and change the color. I name it head and put the tag align to spline on it. I add our tracer to the spline path, set the position at 100%. And we can see how it follows the end of the spline. But you can notice that it is slightly behind. Why is this happening? Because we attach our null through the expression priority tag after the tracer generator. Expressions goes before generator, so we need to change the priority to generator. Now there will be no lag. I will use primitive for visualization, so I add a cone inside the head. Reduce its size, change its orientation, raise it a little, recolor it. I reduce the radius. Let's see how it looks with thickness. Excellent. For now I disable the thickness. Let's add a small platform on top. Now let's set up the guide rails. Create a cylinder, reduce its radius, change its orientation. I place it in the center of the scene. Then apply constraint tag to the cylinder in transform mode. And now we need to decide which parameters it will copy. We definitely turn off the rotation and keep the position, but in the constraint tab we need to turn off all unnecessary parameters. We know that our object will move exactly along the y-axis, so we leave it there. We know that it will move along the x-axis. We leave it, so we turn off the z-axis. We place the head and the target. The cylinder has moved lower. We can move it higher using offset. Let's check it from top. The cylinder is still located at the center of the scene along the z-axis. You also need to remember about priorities. Set the generator. Let's see how it works. Let's look from the top view to see if the object is moving along the z-axis. Awesome. Next I add another guide rail, but each printer has a head that looks different and the guide rails are positioned differently, so you need to understand the principle of operation of constraint and the choice of axis. And then everything depends on your tasks. I duplicate the cylinder and I change the axis on which it will be attached. X to Z, and I need to change the orientation of the cylinder itself. Next, I need a 0 by X coordinate. Let's check at the result from above. As a result, each cylinder has one of its axes blocked. At the same time, the other two axes work and repeat the movement of the fixed null object to our spline. To avoid confusion, don't forget to rename everything. Next, we need to create flexible tubes that go to the top of the head, so we create a matrix object, mode object, select our tracer. I set its number to 1, reduce the cube, move it to the end of the spline, and turn off the loop function. Thus, the cube has moved to the end of the spline, in the same place as the cone. I'll turn off its rotation, recolor it, and reduce it a little more. Let's create a new null for our tubes. Put the matrix inside, create one more null. Tube 1, let's try to make two tubes. I named the matrix T1, it's gone. Happens. I duplicate it and name it T2. Let's move the first one higher. Move the second one even higher. Next, we raise mouse spline to the very top. We wrote down the number, put it in here. We are at the very top. Create a new null. We set the visualization as a sphere. Make it smaller. I also color it in pink. I name it T3. Put it higher. And duplicate it. Let's further reduce the size to 0.5. T3, T4, and T5. Next, I create a tracer, put it next to the nulls, and we put the first matrix, the second one, and our new nulls. Then connect them by changing the tracing mode to connect all objects. What result did we get? We have two matrices attached to the head, and there are three nulls that are in static position. If we animate mouse spline, then we see this result. Splines are straight. We change the spline type in the tracer to B-spline and set the interpolation to uniform. We can now move nulls freely to change the shape of our tube. Awesome. Now we create a sweep. Put a tracer in it, create a circle, put it inside, reduce radius, more, check a polygon density. You can remove polygons from the circle for optimization, but increase them on the tracer. I'll set 16. Excellent. Let's make a second tube like this. I will move nulls along to axis. You can also move the matrix. Let's move the matrix of the first one to the other side. Check the result. Of course, I show everything on primitives. You can also have your own model that fulfills your needs. The only advice I'll give you on flexible tubes is the fewer points you use, the smoother the spline you'll get. Therefore, it may make sense to delete these points. Leave these out and pull them closer here. So get rid of the extra points that adjust the shape of your flexible tube. It is still quite flexible, and if you add too many nulls, the movements will be unnatural. We are done with the first trick. To visualize this project, I bought a 3D printer model. It turned out to be exactly the same that we selected in the Cura settings. And its special feature is that its head stands still and the platform goes down when it prints a model. It looks like this. So now we are going to modify the first trick so that it works exactly so that the model is printing, but at the same time it is going down with the platform. And the head is moving along two axes, but at the same time stays still at the y-axis. In my setup I used the match size node from Dominic Ruckley to lower the platform. He prepared a node that partially repeats the functionality of the match size node from Houdini. I recommend visiting his channel. He has prepared a huge number of very cool nodes for Cinema 4D, but we will go in a simpler way. To change the printing direction, we will need to do a couple of simple manipulations. First, let's finish the printing process on the set percentages. Bring it to the top. Next, we put the geometry axis in mouse spline. Minus 100% will be changed to 100%. Switch to the side view and raise our shape to the printer's head using offset. 30. Let's put it right at the bottom. Something like this. We can already see that the head is standing still. Let's take a side look at how correct this is. Let's get closer to the head and look at the guide rails. Yes, it really stands still. So I don't even see the point to turn off the y-axis of our guides, because the geometry axis node basically does everything for us. Next, we need a platform. To make a platform, we'll do the following. Let's also complete our mouse spline. This is not necessary, but it will make it easier to build our platform from 0 coordinates. I copy the head, delete everything inside it, rename it to bottom, set the align to spline percentage by 0, so we have null object near 0 coordinates by the y-axis. You can see that this null moves along with the entire model. Next, we just need to create a platform and put it inside bottom. This way we get a rig that works in the opposite direction, that is, it starts printing from the top and the platform goes down with the model. Let's visualize it all with thickness. The load on the system increases and we see that frames per second have become smaller, but this is not really important for the final render. The main thing is that the technique works. Okay, we are done with the main setup. All the highlights are covered, so I hope that this tutorial was useful to you and you learned something new today. I'll also give you a couple of tips on rendering this whole thing. First, there are a lot of materials used to print 3D models, but the wall thickness of the final models is usually small, so some types of plastic can show through. Therefore, I advise you to play with the subsurface scattering parameter when configuring the model material. I'll show you the difference in my render. Before, after. And the second. This is motion blur. If your 3D printing animation is accelerated like mine, then the printer head changes its trajectory many times per second. At the same time, the trajectory is quite complex. However, in stock settings, such as redshift, there are 2 transformation steps. I recommend increasing them. I did a couple of tests and this is what the standard 2 steps 4, 6, 8 and 10 look like. Don't skip this parameter. We also have flexible tubes in the scene. Unlike the printer head, which is shifted in position and it doesn't have any problems with motion blur, the tubes won't have any motion blur since they don't move. Pay attention to the anchor point. Instead, points move inside the tube object. So, to enable blurring for pipes, activate deformation blur. This should be done if the points of your object change position under the influence of deformers or generators, as in our case. However, problems can occur with the objects that have an unstable topology. The 3D model that we print during the printing process will increase the number of its points with each frame. Redshift won't like it and it will give errors. Still render, but spend time calculating this problem. So we need to forcibly disable deformation blur for this object. Put the redshift object tag on it. In the motion blur tab, enable override and set the motion blur drop-down menu to only transformation. Deformation blur is no longer applied to this object. For this parameter, the number of steps is just as important as for transformation steps. For the final render, I set 9 steps for both parameters. Let's also look at how to optimize a spline using Houdini. The first thing we need is the end parameter in most spline being set to the final value, until the moment when we have extra splines. Let me disable tracer and so we see only most spline. Excellent. Apply its position via current state to object. I'm taking this to a new scene. And we export all this stuff to Alembic. Why not in other formats? I couldn't export array of splines so that Houdini imports them correctly. That's why Alembic does the best job in my case. The only thing that you need to specify in the settings is splines. By default this option is disabled and the file will be empty. I also reset the number of frames to 0. This doesn't affect anything, we have static, save it. Next, create a geometry in Houdini. Create Alembic inside it. We put our file in the file name field. And we can see that the splines were imported. I will create a null so that we can see the statistics of our geometry. I take it out and pin it here. We can see that we have 1 point, 1 primitive and 1 vertex, which is not entirely correct. Therefore, in the alembic node parameter we need to set load as to unpack alembic delayed load primitives. And we will immediately see that we have 271,000 points, half as many primitives and vertices as points. Add fuse node. A brief insert from the editing table. Don't forget to reduce the snap distance parameter if the size of your model is small, so that no extra points are stitched together. And we can see that our number of points has decreased twice, but the number of vertices remains the same. And if we get closer and after the fuse node, we will try to change the position of any point. The points appear to be connected, but when you export this state to Cinema 4D, they will still be disconnected. I delete the position change. And we need to reduce the number of vertices as well. We will do this using the join node. Apply it after the fuse node. We can see that some segments have been stitched together. This is not the effect we need. Moreover, we now have 1 primitive. In the end, it's all one single spline. We check the only connected checkbox and face the problem that we have polygons now. The logic in Houdini is such that closing splines turns them into polygons. So now we need to convert polygons to splines. This is done using the curve from edges node. Polygons turned into splines, and I suggest you to pay attention to statistics. The number of points has decreased almost twice from our original value. Number of primitives is the number of connected splines, and the number of vertices nearly matches the number of points. You can already work with this, so we export the result of our null to OBJ. Import our optimized spline from Houdini. I pull it out of the hierarchy, disable more spline for now, and notice that our new spline aligns perfectly in position. I rename it. And all we need is to replace the source spline parameter in mospline with a new one. All dependencies will be updated. I hide the spline from Houdini, turn on mospline, and we see that the 3D printer rig is working. Nothing is broken. However, the number of points has decreased significantly, as you can see by turning on the point mode and selecting our original spline with 290,000 points and selecting a new spline with 138,000 points. That will affect the speed of our setup when you enable thickness. Now we can even try sweep instead of our setup. And it looks pretty good. Until we see these segments. Because Houdini divided closed splines at the very end and they are not connected. So if you only show the model from the front and you can't see the back, you can use sweep. However, in my example I did it through our main setup. And also don't forget to enable bevel to improve the shading. Bevel greatly affects the system load in this case, but the result will be much better. And also don't forget that we may have bugs because of the thickness generator, so it's better to switch it to advanced mode. As we can see, everything is gone. All bugs have disappeared and we can see the final structure. Pixels are pixels, but I finally received a truly printed statuette. This model was printed on a 3D dot matrix printer, and here is a layer by layer visualization in the slicer of this printer. For my statuette, the following supports were needed. And printing on such printers looks like a real magic. Now I have not only digital copy, but also physical copy of the model for this tutorial, for which I thank Sergikkas who printed it. Visit his channel and cheer up the old fellow. That's all for sure now. I hope this material was useful to you. Feel free to join my Telegram channel. I don't post very often, but when I do, it's about graphics and other topics. I'll leave a model of the statuette for your tests in the comments below the post with this video. Bye!